Welcome to the lecture number 8 of Theory of Computation. In this lecture, first we will go through what is an Epsilon NFA, then we will go through Epsilon closure, then we will go through how to convert an Epsilon NFA to a DFA. So before going through that, let me first tell you where Epsilon NFA will be used. So let me draw an NFA for representing all the integers. So integers may be, so here 12 may be an integer, 123 may be an integer, plus 12 is an integer. So here I can also write minus 123 as an integer. So here you see plus and minus symbols are optional, and after that you can write any number of digits. Okay, so that will represent an integer. So in order to do that, let me draw a DFA for this one or NFA for this one. So Q0 is the initial state. So plus minus symbols are optional. So what I will do, I will draw a plus. So either it get a plus, it get a minus, or it gets an epsilon. So it will, after that it will go to another state, that is, let's say Q1. So after Q1, it may go through 0, 1, 2, dot 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 9, any symbol. It will go to another state Q2. So now here you see, here Q2 is the final state. So after 0 to 9, you may have any number of 0 to 9 symbols. So 0, 1, dot 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 9, right? So here you see, if I will represent an NFA like this, let me check whether plus 12 is a valid integer or not. So I will start from the initial state Q0. So Q0 by taking plus as input symbol. What is the next state? It will go to Q1. So now Q1 by taking 1 as input. So first I have processed the plus, then I have processed the 1. So Q1 by taking 1 as input, it will go to Q2. So Q2 by taking 2 as input, it will go to again the state Q2. So now you see, after processing the string, so what was the string? The string is plus 1, 2. So after processing the string from the initial state, I am able to reach the final state. That's why I will say that plus 1, 2 is accepted by this NFA, or plus 1, 2 is accepted by this Epsilon NFA. Here you see why it is called as an Epsilon NFA, because by taking Epsilon as input also, it may go from Q0 to Q1. So now let me check whether 1, 2 is a valid integer or not. So I will start from the Q0 state. So Q0, so 1, 2, 1, 2. Before it, any number of epsilons can be there. After it, any number of epsilons I can put, because epsilon is a string of length 0. Between that also I can put an epsilon. So here my string is 1, 2. I want to check whether 1, 2 is a valid integer or not. So first what I will do, Q0 by taking epsilon as input, it will go to Q1. Then Q1 by taking 1 as input, it will go to Q2. So now Q2 by taking 2 as input, it will go to the final state Q2. So now you see, after processing the string 1, 2 from the initial state Q0, I am able to reach the final state Q2. It means Q2 is a valid integer. Okay, so in this case, in such scenarios, what we will do, we require a transition for epsilon also. Epsilon means it will not take any input, but still it will change the state. And such kind of epsilon transitions if appear in an NFA, then we will call it as Epsilon NFA. So what is Epsilon NFA? When an NFA contains epsilon transitions, then it is called as Epsilon NFA. So here you see, here I have drawn a transition diagram for real numbers, decimal real numbers. Decimal real numbers means either it may have a plus symbol, or it may have a minus symbol, or it may not have any plus or minus symbol. Then it may have 12.32. So it will have a integral part, it will have a fractional part. So this will be separated by a decimal symbol. So this is the NFA for epsilon. This is the NFA, Epsilon NFA for a real number, which represents all the decimal numbers. Right. So now let us go through how to convert an Epsilon NFA to DFA. So before converting an Epsilon NFA to DFA, first we need to know one more thing, that is called as Epsilon closure. So what is Epsilon closure? So state Q is in Epsilon closure of Q. So it means what? If I want to find the Epsilon closure of, so Epsilon closure of Q0, it means by default it will contain Q0 as in epsilon closure. So if I want to find epsilon closure of Q1, then what I will get? By default I will have Q1 in epsilon closure. So this is the basis, okay? So state Q is in epsilon closure of Q. So every state Q is in its epsilon closure. Next is induction step, okay? If step P is in epsilon closure of Q, so for example, let me draw a diagram over here in order to make you understand. So let a state Q is there. So from Q, let a epsilon transition is there to a state P. Okay. So here the epsilon closure of E close of Q will be what? Will be itself Q, and as by taking epsilon as input, epsilon means no string as input, it moves to state P. So P is also in epsilon closure of Q. So here you see, if a state P is in epsilon closure of Q and there is a transition from state P to state R. So from state P to state R, if there is an epsilon transition, so let me write it as R, then R is also in epsilon closure of Q. So here you see epsilon closure of Q, in epsilon closure of Q you are having Q and P. Now if there is a epsilon transition from P to R, then R is again in the epsilon closure of Q, right? So now let me find the epsilon closure of all the states of this transition diagram. So epsilon closure of Q0 is by default Q0 will be there. Now you see from Q0 to Q1 there is an epsilon transition. So from Q0 you can reach Q1 without taking any input string. So what you will do? So Q1 will also be in epsilon closure of Q0. Now let me find the epsilon closure of Q1. So epsilon closure of Q1 means, so Q1 by default will be there. Next we will look at the epsilon transitions from Q1. So from Q1 there is no epsilon transition. So epsilon closure of Q1 will only be Q1. Next let me compute the epsilon closure of Q2. So now in epsilon closure of Q2 I will have Q2. Then what I will have? Then I will have to check from Q2 whether is there any epsilon transition. There is no epsilon transition from Q2, so only Q2 will be there in the epsilon closure of Q2. Next, let me compute the epsilon closure of Q3. So epsilon closure of Q3. So here it will be okay. Open bracket, close bracket, open bracket, close bracket. Right. So epsilon closure of Q3. So Q3 will be there. So now I have to check whether from Q3 is there any epsilon transition. Yes, from Q3 there is an epsilon transition to Q5. So Q5 will again be present in the epsilon closure of Q3. Now let me compute the epsilon closure of Q4. So in epsilon closure of Q4, I will have Q4 state, and next I will have to check whether from Q4 to any other state whether is there any epsilon transition. There is no epsilon transition from Q4, so Q4 will itself be in the epsilon closure of Q4. Let me compute the epsilon closure of Q5. So the epsilon closure of Q5 by default it will have the same state Q5 in epsilon closure. Now let me check from Q5 is there any epsilon transition? No, there is no epsilon transition, means only Q5 will be there in the epsilon closure of Q5. So I hope all of you have understood epsilon closure. Next let me go through how to convert an epsilon NFA to a DFA. Okay, so I have already told you while converting an NFA to DFA we are following the subset construction method. So here also we will do the same thing, but here while computing the states we need to have a look at the epsilon closure, right? So let me first convert this one, then I will go through the algorithm so that you can easily understand that one. So here what I will do, I will first start from what is the initial state while converting from NFA to DFA. What we are doing, we are starting from the start state. So here what is the start state of the epsilon NFA? It's Q0. So Q0 means I just have to look at the epsilon closure of Q0. So what is the epsilon closure of Q0? It's Q0 Q1. So what I will do, I will start from, so here these are the states. So here what are the input alphabets? One input alphabet is plus. What is the other input alphabet? it's minus. Next, what is the other input alphabet? 0, 1, 2, dot 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 9. So 0 to 9. So these are one input alphabet. Okay. So every time here you see when you are getting 0 to 9, so you are in the same state. 0 to 9 you are in the same state. 0 to 9 from Q2 you are making a transition to Q3. 0 to 9 you are making a transition from Q1 to Q4. So every time you are getting the 0 to 9 at a place. That's why I have kept it at a same place. But you may also separate them. Okay. So now let me, is there any other input alphabet? One is plus, minus, 0 to 9. Another one is, here you see the decimal symbol dot. Okay. So we are having another symbol, that is the decimal symbol dot. So now let me do this offset construction method. So I will start from the initial state. What is the initial state? Q0. So Q0 means what? I have to look whether what is the epsilon closure of Q0. The epsilon closure of Q0 is Q0 Q1. So I will start from Q0 Q1. Now Q0 Q1 by taking plus as input. What is the next state? So here is with Q0 Q1 by taking plus as input. The next state is Q1. So I will have to look at the epsilon closure of Q1. Epsilon closure of Q1 is Q1. So here what I will do, here I will write it's Q1. So now Q0 Q1 by taking minus as input. What is the next state? It's Q1. So I have to look at the epsilon closure of Q1. So as the epsilon closure of Q1 is Q1 itself, so I will put Q1 over here. Now Q0 Q1 by taking 0 to 9 as input. What is the next state? So from Q0 there is no transition from 0 to 9. So here it will be 5. Now from Q0 I have to check what is the next state if I will take dot as the input symbol. So from Q0 there is no transition for dot. So here I will write 5. So now what is the new state over here? The new state is Q1. So here I will write Q1. Right? So Q1 by taking plus as input. So Q1 by taking plus as input, there is no next state. So here it will be 5. Q1 by taking minus as input. So Q1 doesn't take minus as input. So here it will be again 5. Next, Q1 by taking 0 to 9 as input. So Q1 by taking 0 to 9 as input. So the one next state is it goes to itself Q1 and it again goes to another state, that is Q4. So here I need to look at what is the epsilon closure of Q1 Q4. So Q1 is itself Q1, Q4 is itself Q4. So here what I will do, I will make a subset, that is Q1 Q4. Right? Now Q1 by taking dot as input symbol. So Q1 by taking dot as input symbol. Here you see there is one transition Q1 to Q2. So I have to look at the epsilon closure of Q2. So epsilon closure of Q2 is Q2 itself. So here what I will write? I will write Q2. Now here there is a next new state, that is Q2. So what I will do? So there are two new states. One is Q2, one is Q1 Q4. So first let me go for Q2, right? So Q2 by taking plus as input. So Q2 by taking plus as input, there is no next state, so it's 5. Q2 by taking minus as input. What is the next state? There is no next state, it means it's 5. Q2 by taking 0 to 9 as input. So Q2 by taking 0 to 9 as input, the next state is Q3. So here what I have to see, while writing Q3, I have to look at the epsilon closure of Q3. So what is the epsilon closure of Q3? It's Q3 Q5. So here what I will write, instead of Q3, I will write Q3 Q5. Now Q2 by taking dot as input. So Q2 by taking dot as input, there is no next state. No next state means I will simply write 5. So now there is a new state, that is Q1 Q4. So here what I will do? I will do Q1 Q4. So Q1 Q4 by taking plus as input. So here what I will do? I will have to check Q1. I will have to check Q4. So Q1 Q4 by taking dot as input. So Q1 by taking dot as input. What is the next state? So Q1 by taking dot as input, the next state is Q2. So here I will write Q4. Q4 by taking dot as input. So Q4 by taking dot as input. What is the next? So Q1 by taking dot as input, the next state is, so Q1 by taking dot as input, the next state is Q2. Okay, so I have written Q2. Q4 by taking dot as input. So here you see Q4 by taking dot as input, the next state is Q3. So Q3 means I need to look at the epsilon closure of Q3. So epsilon closure of Q3 is Q3 Q5. So here it will go to Q3 Q5, right? So next Q1 Q4 by taking dot as input, Q1 Q4 by taking dot as input. What is the next state? It's Q2 Q3 Q5. So this one is Q1 Q4 5, this one is 5. Q1 Q4 by taking dot as input, the next state is Q2 Q3 Q5. Now Q1 Q4 by taking 0 to 9 as input. So Q1 by taking 0 to 9 as input, it remains in Q1. So Q1 Q4 by taking, so Q1 by taking 0 to 9 as input, it goes to Q1 and Q4. So Q1 Q4. Now Q4 by taking 0 to 9 as input, what is the next state? There is no next state, so it will remain in Q1 Q4. So now you see Q2 I have done, Q1 Q4 I have done. Now I have to do Q3 Q5. Okay, so Q3 Q5. So now Q3 Q5 by taking plus as input. So Q3 by taking plus as input, there is no next state. Q5 by taking plus as input, there is no next state. That's why it is 5. Q3 Q5 by taking minus as input, it's again 5. Q3 Q5 by taking 0 to 9 as input. So Q3 Q5 by taking 0 to 9 as input. So Q3 by taking 0 to 9 as input, 0 to 9 as input, it remains in Q3. Q5 by taking 0 to 9 as input, it's 5. So what is the union of this one? You will get Q3. But here you see Q3 means you have to look at the epsilon closure of Q3. Epsilon of closure of Q3 is Q3 Q5. So here itself it will represent Q3 Q5, so that here you will get Q3 Q5. So here you will get Q3 Q5. Now Q3 Q5 by taking dot as input. So there is no transition from Q3, there is no transition from Q5. So here it will be remained as 5. Now there is another new transition, that is Q2 Q3 Q5. So Q2 Q3 Q5. Okay. So Q2 Q3 Q5 by taking plus as input. So Q2 Q3 Q5 by taking plus as input, there is no next state, that's why it will be 5. Q2 Q3 Q5 by taking minus as input, no next state, 5. Q2 Q3 Q5 by taking 0 to 9 as input. So what you will do here? You will do Q2 Q3 Q5 by taking 0 to 9 as input, this one by taking 0 to 9 as input, this one by taking 0 to 9 as input. So Q2 by taking 0 to 9 as input, it's Q3. So Q3 means it will keep Q3 Q5, because you see in epsilon closure of Q3 you are having Q3 Q5, right? Okay. So Q3 by taking 0 to 9 as input. So Q3 by taking 0 to 9 as input, it remains in Q3. So it remains in Q3. Q3 means its epsilon closure is Q3 Q5, right? Next, Q5 by taking 0 to 9 as input, it's 5. So what is the union of this? You will get Q3 Q5. So here you will get Q3 Q5. Now Q2 Q3 Q5 by taking dot as input. So Q2 by taking, so here let me write Q2 by taking dot as input. What is the next state? There is no next state, so it's 5. Q3 by taking dot as input. What is the next state? There is no transition, so it's again 5. Q5 I take dot as input. What is the next state? There is no next state. So here it should be 5. So here you will get a 5. So now you see we have found out all the reachable states from the subsets, right? So now we have to find out what is the initial state. So in this epsilon NFA, what is the initial state? The Q0 is the start state. So now here you have to look where Q0 is there, that will become as the start state. So here it will become the start state, right? So that's why I marked with an arrow mark. Now which one is the final state? So here which one is the final state? Q5. So now where you will find Q5 as an element of the set, there you have to make it as final state. So here Q3, Q5 is a final state, I have marked with star. Q2, Q3, Q5 is a final state, I have marked with star. Right? So I hope all of you have understood how to convert an epsilon NFA to a DFA. It's simple. It's similar to how to convert an NFA to DFA. But here what you have to do while computing the states, you have to look at the epsilon closure. So in the epsilon closure, if you are having a state, subset of states, then you have to include the set of states as the subset. So I hope all of you have understood this. Next, let me go through the algorithm. Okay. So let epsilon NFA is defined by the 5 tuple QE. So here E is epsilon NFA, right? So QE input alphabet delta E Q0 FE. So now if you want to find an equivalent DFA, so that will be let be represented by D. So QD input alphabet. So here you see the input alphabet will not change. What will be the input alphabet of NFA, epsilon NFA? That will be the input alphabet of DFA. Okay. Next delta D will change, QD will change, FD will change. Okay. So what is QD? QD means the states of the DFA. So QD is the set of subsets of QE. So here if there are n states, so here you will have 2 to the power n states. But we will not go through all the n states. What we will do, we will go through the reachable states, or that is also called as accessible states. So we have started from the initial state. So which state we will reach, we will only compute that state. Okay. So accessible sets of D are epsilon closed subsets. So I have already told you in this example. So here you see when you are here the initial state is Q0, right? But here I have started from Q0 Q1. Why? Because Q0's epsilon closure is Q0 Q1, right? So that's why while computing this, what you have to do, this states, while you are looking at the states, you have to find the epsilon closed subsets of Q, right? So this is how you will find the states of QD, that is the DFA, which is equivalent to epsilon NFA. Next QD, small QD means it is the initial state. So what is the initial state? So epsilon closure of Q0 is the initial state of the DFA. So here you see in the previous example, what is the initial state of DFA? Q0 Q1. So what is Q0 Q1? Q0 Q1 is the epsilon closure of the initial state Q0, right? So what is the initial state? Initial state in DFA is nothing but the epsilon closure of Q0. Next, what is the final state? Final state means the states which contains at least one accepting state. So is the state which contain at least one accepting state of epsilon NFA, that will become as the final state. So in our example, you see what are the final states? In this epsilon NFA, Q5 is the final state. So where you will find the final state Q5, that you have to mark it as the final state. So here Q3, Q5 is the final state, and Q2, Q3, Q5 are the final states. So next, while computing the transitions, what you are doing while computing the transitions, let the subset contains P1 to Pk states. So what you will do, you will find the transitions from Pi to a symbol, and you have to make a union of this. So here you see I have done. When I want to compute the Q2, Q3, Q5 when it goes through 0 to 9. So what I will do, I have computed Q2 when it will go to 0 to 9, what is the next state? Q3, what is the next state? Q5, what is the next state? Next, what I have done? Next, I have made an union of all the transitions. So the same thing that has been written over here. Then after you have found the union, what you have to do? You have to look at the epsilon closure of all the states. So here you see, here while computing this one, let's say, okay, so first you have computed q1 by taking dot as input, the next state is q2, q4 by taking dot as input, the next state is q3. So q3 we are not taking q3, we are taking the epsilon closure of q3, that is q3 q5. So that's why here we have written q3 q5. So q1 q4 by taking dot as input, what is the next state? The epsilon closure of all the states, that is q2 q3 q5. So this is all about the algorithm. I hope all of you have understood it.